All right, function notation. So explicit functions are frequently written in function notation here. So if you're given like an equation y equals 3x squared plus 1, that would be a parabola. Your function notation is just going to be, instead of y, you're seeing f of x. It's really the same exact idea. Okay. This is read as f of x and interpreted as the value of the function f at x. Okay, so now we have evaluating functions, and we're going to evaluate them for a given value. So if you read this, you're first given the function, then this is like your question right here. So this is the question coming after the semicolon. What is f of negative 5? And so to do that, well, if you just look at what the question is doing, if I started with f of x and then my question says f of negative 5, what am I really doing? Well, where I see x, I'm putting negative 5, right? So that's really what's going on here. And before you replace these, please, please, please do not forget to put them in parentheses. Okay, so this would be negative 5 squared. So that should end up being positive. If you don't put parentheses, you might get your answer wrong. Minus 6 times negative 5 and then plus 23. So negative 5 squared is 25, and then that would be plus 30 plus 23. So f of negative 5, add those together and you're getting 78. Okay? All right, next one. We're evaluating h of x, and it wants to know what h of 9 is. So where I see x, I'm putting 9. Equals 7 minus 9 squared. And then you're really just doing PEMDAS from there, order of operations from there. H of 9 would be 7 minus 81. So h of 9 is negative 74. Okay, hopefully you remember all these and this isn't too hard. It's going to get a little more difficult on the back. Okay, P of 4, you would just plug that in. We haven't done a fraction, so that's okay, we'll do 9. All right, so P of 4, where I see x, I'm going to be putting 4 everywhere. So P of 4 equals 4 plus 1 all over 2 times 4 squared plus 4 times 4 minus 13. Okay. So that equals 5 over, if you do all that out, I would honestly just, if you have a graphing calculator, type this exactly how you see it in the calculator and press equals. Okay, don't overthink it. You don't have to do step by step. Type that in, press equals, and you should get 35. You could even type the entire thing in, press equals, and it will give you 1 over 7 and simplify all of it for you. Okay, that's P of 4. All right, I'm gonna skip 10 because that's pretty simple, just plug it in. 11 is a square root, so I want to do that, and if for some reason we have to simplify, you need to remember all your simplifying square roots rules. Okay, so where I see x, I'm going to put negative 15. So q of negative 15 equals square root of 6 minus 2 times negative 15. Okay, and so that ends up nice, equals 6 plus 30, which is 36. So q of negative 15 is the square root of 36, which is 6. So make sure you are simplifying that fully. Okay, we have quite a few. Okay, let's do an absolute value. It's been a long time since we've done that, and then we'll talk about 13. So 12 and 13, and then we'll move on to the bottom. So where I see x, I'm going to put negative 10. So P of negative 10 equals the absolute value of 1/2 times negative 10 minus 14, absolute value, okay? And so talking calculator wise, I would literally type this into the calculator and press equals, and you should get negative 19. So now I'm at the absolute value of negative 19. And so P of negative 10 is 19. All right, let's do 13. F of 4, when you're given the function f, here I'll just write it again. Okay, so I'm gonna plug in 4 where I see x. Okay, and then when you're doing negative 3 to the 4th in your calculator, you really could type negative, that little negative sign, 3, and if you want to do it out with the hat key, this needs to be in parentheses, okay? So in your calculator, you're going to type negative 3, parentheses, sorry, negative 3, close it, then hat 4, okay? And that should look like on your screen this, okay? That's what you need to do. Negative 3 is in parentheses, so you need to make sure it's there, okay? Or you do negative 3 times negative 3 times negative 3 times negative 3, so we should be getting out a positive 81. For some reason, we're still kind of struggling with those negatives, and so that's 405. Okay, let's move on below, because here your things you're plugging in are also either expressions or just monomials, so they're not just a number, okay? So let's look at 15. Now we're asked for f of 3y squared. So instead of just a number, you're actually plugging in something with a variable, a monomial here, okay? So same thing though, I'm still gonna put parentheses around everything before I plug it in, and then we'll have to use our exponent rules to simplify. So f of 3y squared is 3y squared to the third plus 3y squared squared. There you go. Okay. And then you can't forget your exponent rules. So that 3 needs to be to the third, and the y is to the 2 times 3. Then 3 needs to be squared, and then y to the 2 times 2. So here I'm at 81, y to the 6. Okay. 3 to the third is not 81. Sorry. Sorry for the fart noise too. That's okay. All right, 3 to the third is 27. Then y to the 2 times 3 is y to the 6. Okay, that looks better. All right, now 3 squared, y to the 4th would be 9, and there's a plus between it, so 9y to the 4th. There you go. Okay, let's try with negative 5c for 16. Plug that in for x, and remember, you're only doing it where you see x. So g of negative 5c is 3 times negative 5c plus, minus 10, minus, okay, all over negative 5c plus 5. Okay, excuse me. So that's going to be negative 15c minus 10 all over negative 5c plus 5. Okay, and I'm going to skip this one, so I'm going to keep going here because we can actually keep simplifying. All right, so not only do you really need to plug things in, you really need to simplify as much as you possibly can. And when I notice this, I have negative 15, negative 10, negative 5, 5. All of those have a 5 in common, okay? So factoring out a 5 or dividing everything by 5, either way, we should be able to reduce this, and that you really do need to do that. So negative 3c minus 1 all over negative c plus 1. That is not the only way to write this. It's just a solution. Okay, so make sure you plug in and also reduce. All right, last evaluating has a 2a plus 7, and then also something squared. So it's going to take a little bit for this one. All right, so I'm going to kind of fill it in over here. So h of 2a plus 7 will equal 2a plus 7 in parentheses squared minus parentheses 2a plus 7 minus 1. Okay, so I need to square this, which means the binomial times the binomial. Don't forget that there is also a middle term. So it's not just 2a squared and 7 squared. There's a middle term. So that's 4a squared plus 28a plus 49. And you can do that out the long way if you want. Then I have to distribute the negative here. So minus 2a minus 7, and then bring down minus 1. Okay. All right, so now I'm at 4a squared. My a's combined, so plus 26a plus 48. Okay. I forgot the minus 7, didn't I? Okay, so I need to take one more step. So 4a squared plus 26a plus 41. There we go. Okay, so that is number 17. All right, and very last idea very quickly is using the graph to find each function value. So when you're given this, you're really asked to f of x, right? And f of x. So it wants to know what the y is when you are at an x of 1. Because if you looked at this, f of x will be 1, so what is the y? That's what we're going to read the graph to see. All right, so 1 on your x is right here. What's that y value? Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9. Okay? So this f of x is 5. All right, so 21 wants to know what the y value is at x of 5, which is 1, 2, 3, 4, 5. Okay, so I'm going to draw a line up so I can see where my y hits. Right here. What is that y value? 1, 2, 3, 4, 5, 6, 7. So this is 7. 1, 2, 3, 4, 5, 6, 7. Okay. All right, so number 20. F of negative 2. So what is the y value when x is negative 2? All right, let me do that in a different color. So negative 2, right here. What's that y value? 0. Oh, this would be negative 2, 0. I guess you could have done that with all of them. You could have found coordinate points where these hit and then stated the y. That works too. But the y here is 0. Okay, let's do that for 22 then. So 22, f of 0 means where the x is 0. Well, that's hitting the graph right here, which is the point 0, negative 5, 6, 7, 8. Okay, so f of 0 is negative 8. That's the y value on that graph. Okay, that's it.